I'm Adam from RFOXiA, from our real lab. Today we are answering why professional-grade long-range wireless has cost $5,000 for decades and whether that price was ever justified. Let me walk you through the price gap, not the marketing version, the engineering version. For most of the last 30 years, if you needed wireless communication beyond a few hundred meters, real range, in the field, on a drone, between vehicles, across terrain, you had two options. You bought military or industrial hardware at prices starting around $5,000 and going up from there, or you accepted that your project simply could not do it. That was the choice. There was no middle option. The commodity Bluetooth modules you find on breakout boards reach somewhere between 80 and 100. That is the price gap and why it existed. Now let me show you the hardware that closes it. This is the range claim in hardware form, 50 kilometers between two modules, 5 kilometers paired with a smartphone. That is not an amplification story. It is a receiver sensitivity story. The range exists because the module was designed to hear weak signals, not shout louder. 2 megabits per second across that range. Most long-range systems sacrifice data rate for distance. This module does not make that trade. Drone telemetry, sensor streams, control packets, all of it moves at full speed across distances that commodity modules cannot reach at any data rate. The STM32B07CCV6 is the processing core. It manages the BLE stack and runs user applications on the same silicon. No external microcontroller required for most use cases. The chip was selected because its receiver architecture supports the sensitivity figures this module depends on for its range performance. 57 by 47 millimeters, the antenna extends to 140 millimeters, fixing frame holes at 54 by 34 millimeters for mounting. This is a module designed to go into real hardware on drones, robots, field equipment, and not sit on a workbench permanently. The module connects directly to the RFOXiA GNSS module, sensors module, and motor and battery management board through a defined interface. Autonomous systems need location, environmental data, and motor control simultaneously. This module provides the wireless link that holds all of it together. The RFOXiA Connect app pairs with this module over Bluetooth and provides a PS5-style controller interface, live GPS map, and real-time sensor display on your phone. No internet connection required. The control range is determined by the module, which means up to 20 kilometers between phone and drone. BLE Chat turns this module into an internet-independent communication node. Text, voice, and calls between RFOXiA users without infrastructure. Disaster response, remote expeditions, field teams operating outside coverage. The same hardware that controls your drone also replaces your phone network when the network is gone. Full source code access via SWD programming interface. The module ships ready to use, but the firmware is yours to modify. This is not a black box system. If your application needs behavior that the default firmware does not provide, you write it. The AI firmware builder in RFOXiA Club accelerates that process significantly. The integrated RTC crystal provides hardware-level timing precision independent of network synchronization. For navigation systems, sensor logging, and timestamped telemetry, accurate local timekeeping is not optional. This is included on the module, not added as an afterthought. Qualification overhead, and the absence of anyone willing to close the gap. The gap was always closable. It required selecting a chip with -104 dBm sensitivity, designing the RF front end with external amplifiers to complement that sensitivity, and refusing to accept that the $5,000 price point was a law of nature rather than a consequence of who the market had been serving. That is the entire explanation. The physics did not change. The market structure changed when someone looked at it from outside the market.